Hello, my name is Amanda Tait. I am an applications engineer at Metrology Software Products, and I'm going to demonstrate how to program NC-PerfectPart part locator programs in Siemens NX. I will be using Siemens NX software version 10, so expect there may be differences with the user interface between software versions. We do require a minimum version of Siemens NX 10 to be compatible with our plugin, which is in the form of a part file or .prt. The plugin is to be used solely for outputting MSP probing operations. So let's begin by opening a new application. First thing is to select the license, utilities, select bundles, and the license. Okay, mine's already selected, so that's great. I'll then open a new application, select blank, and you can give it a name. And select the file path where it will be saved. I like to save it at this point. Right, now if we insert our CAD, so that's file, import, and then whatever file type you will be using. I'm using IGES, but you can use any that you wish compatible with Siemens NX. NC-PerfectPart requires a CAD model of the same datum in STL form. Okay, great. So there's our CAD model. So it is important that datum we use to program our part, it matches the machining datum. This is so that any compensated errors will be transferred to the machining, such as during part alignment we will apply a rotation around ABC and a translation of X, Y, and Z to the datum. The next thing is to select our application in this top menu and manufacturing, and this should bring up your CAM setup box. We'll use CAM General, and then if we open this we can navigate to the MSP plugin, MSP probing operation, and we've got millimeters or inches. That's just going to set your default tolerances. I'll select millimeters and OK to that, and you should see your MSP underscore program in your tree view, and if I expand that there's a child node of MSP probing. So MSP program is the header of your program and will only be output once at the start. MSP probing refers to each process, so your 702 part alignment process or machining check process. So you can have multiple of these, but the order of these is important. If I highlight MSP program and right click and edit, you'll get this dialog box which controls the automation of the whole program, and also the option to select a header, which is various comments. If I go into this automation type drop down box, you'll see NC-PerfectPart auto proceed, which automates the button clicks of NC-PerfectPart application. And then you've got your controller auto proceed, which is the stop button or any buttons on the controller, and full automation, which will bypass any user input, so you'll just have to start your program and away it goes until the end. It will return to the home screen, hopefully, if all the tests have passed, or it will error on the controller with a failed process. To see the processes run, you would go to tags within NC-PerfectPart and select whichever test has been run to view the report. I'm going to click on full automation, and those lines of code will be inserted in the program when I output it at the end. And OK. To configure a process, if you right click on MSP probing and edit, and you'll see all the global variables for your process, such as tool. There's none currently here, so if I just create one quickly for demonstration purposes, solid and probe. Search for that. Great, we have a prober. You have automated part selection. This is gonna eliminate the need to go in and select your part at the beginning of running a process, or rather before running a process. The part name has to match the ID given when adding the part initially into NC-PerfectPart. MSP part. You must select that box for the actual code to be output to your program. And likewise, there's automated serial number selection. I'm now going to select my process. So process, and in this drop down menu you'll see all the processes available. So surface alignment, iterative alignment, pre-machine, post-machine checks. I'm going to do surface alignment. Got the option to change your datum and your home and rotary 0 options. You can choose to output at the start, the end, or the start and end. Because I'm doing a surface alignment and then going to follow it with an iterative alignment straight after, I'm just going to home at start as well as rotary 0 at start. The recall alignment will be ignored during the 702 or any other program that doesn't require a recall alignment. Likewise for save alignment, so if you're running a post-machining verification, then it will just ignore this, so don't worry about the values. Initialize probe is for your operation ID and your probe number, which is MSP internal use. You won't often have to change these unless you're doing the likes of like a whole offset program. Approach and search distance is global values. You've got the option to change these throughout the program. MSP fit gives you the option to restrict the rotation or translations during alignment. These are set up as default when you initially add your part, so you don't have to change these. But if you have, for instance, a fixture down the x-axis which restricts you from probing it, then you can choose not to translate in that axis by, we'll leave it in 0, which gives no translation whatsoever, and select the x-axis, and this will be output to your program. Sub-operations are all the operations of movement or your measurements. To add a new one, just click on this add button here, and it will introduce a new dialog. In your drop down menu you've got all your options, so linear move to point is like your go-to point, rotary is with the rotary axis, go-to point. Surface point, measure sphere, which is a can cycle for measuring a sphere. Comment, if you click on that, anything you type in this box will literally just be output to your program. So if you put like an M0, M0 will appear in your program. Just cancel it. So we'll begin with a linear move to point and specify point, which again brings up a new dialog. You can type your values in here or click somewhere on your CAD. I roughly know the dimensions, so I'm just gonna put a Z height in here, and you'll see this is where your go-to point is gonna go. And OK. And if I select OK to that and scroll down here, I'll just minimize this menu. You'll see the linear point within your sub-operations tree. I'm going to add a further linear point or safe move so the probe doesn't collide with the part. Again, linear move to point, specify point, and I'm going to begin my probing over here, so I'll just pop it there, give it a Z height, okay, and I can test that by rotating it around. It's perhaps a little bit too much. Okay, you can edit this, highlight it, click edit, and you'll see the coordinates here. I'll just drop it down a little. And okay, and you'll see it's dropped down, and it's created this probe movement path. I want to align my part using points on this freeform surface. I want to do that as a point group, so it'll create a geometry of the points to match to the geometry of the CAD. So if I select new sub-operation, I'm going to start a feature. We can give it a name. You would normally name it with something relevant to the feature you're probing. And point, and OK. Again, it's added to the sub-operation tree. And now I want to add my points. So, probe surface point, and if you select the point dialog, we always want to use point on face as the point type. This is because automatically selects the surface normal vector, which is essential. Select object, start there. OK, and you'll see the vectors in the part, which is incorrect. So we want it pointing towards the part. You can give it an approach point, so approach clearance, and just give it a value. We'll do 6 to be safe. It's always good to give it a slightly bigger approach distance for a part alignment. In case it is unaligned, it might collide with the part. And you can also change your tolerances. Default is fine with me. Okay. And I'll add the rest of my points to align the surface. You could create a new sub-op, or what I like to do is select, and then if I just copy that, and you can paste various ones in. This is just because it keeps the same point settings. And then select your next point in line and edit, and reselect your coordinates. It doesn't remember the vector direction for some reason, so you must remember to select the correct vector. Okay, and then just do this for the rest of my points. You should see I have tried to balance these points as much as possible. This is so you're going to get a balanced alignment or unbiased towards one side. Okay. Great. I can see that there's no obvious places the probe is going to collide with the part, but just give this a bit of rotate round. Perfect. You must remember to close off the feature if you have started a feature. So, end a feature. Okay. I'll just close off the last feature that was opened. So in this case, it is the point group. And if I just select OK to that, that is the end of my alignment process. When you finish a process, it's always good to save. I'm not a fan of losing work because I haven't saved regularly. Okay, I'm going to do an iterative alignment now, which just iterates on the existing alignment to get it more in tune, fine-tuned. I shall do it the easy way by right-clicking on my original alignment, copy, and paste. You can rename this if you like. I'll rename it for my sanity. MSP probing 709, which is the iterative alignment process number. 702 alignment process. Then right click, edit, and all the sub operations are good. I want to replicate the same points, but we need to change the process number to iterative. Gonna change my part selection, also the home, that's okay, and I want to recall alignment 1, which was saved during the part alignment process, and I'm going to save it as 2 so I don't save over the original. And OK to that. We'll start our 703 process with a save point, which will match the save point of the last process with alignment. Okay. I'm then going to add in another save point above the bore, which is to be machined. And this will be checked. So I can just select that and you'll see that the save point's now generated there. I'll just increase the Z height on that. Okay. OK to that. I'm going to use a MSPs can cycle to measure the bore to be machined to check it's got enough stock. This measures 6 points evenly spaced around the bore. Give it a name and select center point. You must use arc, ellipse, sphere, center for the type of this. And if you hover over the edge of the bore, it'll automatically select the center. Okay. Point on circumference. You can use point on edge, curve, or the quadrant point. And it will select the point on the edge of the bore. This is just for MSP to work out the orientation of the bore. Okay. Lastly, I will select the feature normal vector. Use curve axis vector. Again, just highlight over the side there. The feature normal vector, we want to reverse that. Okay. That should be out of the center. Perfect. Okay. Because I've selected the bottom plane, I'm going to give it a negative depth. So it should measure 1 mil up from the bottom there. You can change the tolerances for this feature. So the position, which is a tolerance for the X, Y, Z center position. You've got your form, which is circularity of the bore, and upper and lower tolerance is for the tolerance of the diameter. Okay. I'll finish my part with my safe moves. I can just copy and paste these from the start of program. There we go. I'll just pan that view out. Perfect. Select OK to that, and I'm ready to post my program up. Simply select the post process button at the top, or highlight the main program, right click and post processor. Browse to your option file. I'm posting it out in FANUC. Okay. You give you the name of your file here, plus the extension. And it should be ready to post. So if I select OK. OK. It doesn't show the preview unless you specify. So I'll just navigate to where I saved it, which is here. And I'll just open that with Notepad to check it's OK. And wherever you start a program here, you've got your automation calls, automated part selection, which I named MSP test part, and that's the serial number there. Then it goes into the part alignment program 702, and I've saved it as alignment 1. Then you've got all your surface points, which ends the process and begins the 709 iterative part alignment, again surface points. And it finishes with our pre-machine process 703 and the can cycle here to measure that bore.